I want us to now look at the concept of the derivative. We'll start by first trying to justify why we study derivatives. Where is this used? The main focus of this video is that you appreciate how important the concept of rate of change is. The derivative gives us the rate of change. And in many different disciplines, we find this concept coming up over and over again. Unfortunately, what often happens is that students take a math course, they're exposed to this, but then they forget it. And so by the time you're in an engineering course or in an economics course, you find it difficult because you somehow can't relate what you're doing in those courses to what you learned in some math course, like say this one. So I hope that with this video, we get to see why this is important. In many disciplines, we find a concept coming up over and over again, and that concept is rate of change. So whether you're studying physics, or finance or some form of engineering, economics, the concept of rate of change is very important, and it always shows up. It may have different names. So for example, in physics, if we're talking about the rate at which an object's position changes, you can call it velocity. If you talk about the rate at which its velocity changes, you call it acceleration. In economics, you have other types of rates. You have something that's called the marginal cost. So everywhere we have these things coming up, and it's important for you to recognize that all you're dealing with is a rate. So the derivative is important because the derivative is what gives us the rate of change. So let's look at a few examples. Here we have a metal bar surrounded by some form of insulation, and its ends are at, in this case, 100 degrees Celsius, and here 0 degrees Celsius. So this is like boiling water, and this is like melting ice. Of course, heat will flow along this bar from this hot source to this cold sink. Now, if you were to measure the temperature along this bar and graph it, you would get a graph that looks like this. What is important here is that the rate of change in the temperature is uniform. So here the rate of change in temperature is simply called the temperature gradient. And so as you can see, the gradient of this line is constant. It doesn't vary. Now, if you were to have a very similar situation, but you remove the insulation, note that the rate of change in temperature with position along the bar. So notice now, in this case, the rate is not with respect to time. We are looking at how quickly the temperature changes as we move across the bar. So in this case, the rate at which the temperature falls is constant. It does not depend on what position you are at along this bar. However, in this case, initially, for small values of x, the gradient here is fairly steep. As we move along, it's less steep. So the temperature gradient varies. The rate of change in temperature with position is not constant here, but it is constant here. So we'll not discuss this any further because this is not a physics course or an engineering course. But you can see how this concept of rate of change would be important. For an engineer, it's important to realize that as you move along the bar here, the temperature falls quickly, and as you move along the bar here, the temperature doesn't fall quite as fast. Whereas in this case, no matter where you are on this bar, as you move along this bar, the temperature falls at the same rate. This diagram captures the motion of an object that is thrown straight upward. It goes straight up and comes straight back down, and its position at various points in time is recorded in this graph. So at this point in time, 0.5 seconds after being thrown up, it's 6 meters high. Let's assume this is in meters. 1.5 seconds into the motion, it's above 10 meters high, and then later on at around, let's say 2.5 seconds, it's between 6 and 8 meters high, and later on it's back at 0 meters, in other words at its initial starting point. So this object is thrown straight up and comes straight back down. Now if we were to look at the gradient of this, it would give us the rate at which the position, the y position, changes with time. That rate is in physics referred to as the velocity. And so if you were to find out the gradient right here at this point, you would get 15. And so this object is being shot straight upwards with a velocity of 15 meters per second because the rate of change of its position with time is 15 meters per second. As time goes by, roughly around 1.5 seconds, we see that the gradient of this function, of this graph, is 0, which means then that momentarily, instantaneously, it comes to a halt. So this should make sense. If you throw an object upward it has to go up and slow down, and before it comes back down, it has to stop. It can't come back down without first stopping. So where it stops, that's where the gradient is 0, because then the rate of change in its position is 0, its velocity is 0. And of course, then the velocity goes from a positive value to a negative value. So while it's speeding up, strictly speaking, its velocity is now negative. In other words, continuing to decrease from positive values, positive gradients, 0, and then negative gradients. Again, we don't want to go too deeply into this. If you have to do a physics course, then you will do this in much more detail. The point is that we are interested once more in the rate of change. And the rate of change here is called the velocity. What happens to students sometimes is that you forget that many of these things that you study are simply rates, or rates of change. So make sure you understand everything you can about rates of change, so that no matter what subject you're studying, whenever you're dealing with something that's a rate of change, you are much more capable of dealing with it. So if you were to carry out some analysis of this function here, you would see that here the gradient is 15. That means the initial velocity of the subject as it is shot up is 15 meters per second, and then the gradient gets less. So the gradient decreases from 15 to 0. Here the gradient is 0, and then the gradient continues to decrease, negative values, and here you would see that you would get a gradient of minus 15 at this point here. Alright, so let's look at one more example. So in economics courses, we encounter something called the marginal cost. So here is an equation that gives us the cost of producing X items of some consumer product per day. So notice as you increase the number of units you produce per day, the cost drops, but then afterwards it begins to increase. The reason for this would depend on various factors. So you would have to know the ins and outs of the particular industry. So that's not the important point here. The point here is simply that the cost of producing a certain number of items every day initially decreases as you increase the number of items. Notice, as I increase the value of X, I'm increasing the number of units I produce every day. By increasing the number of units, the cost of producing those items falls. But as I continue to increase the number of items I produce per day, the cost increases. So there is a concept called the marginal cost, which is the additional cost incurred when you produce one more item. And one way to get that is to find the first derivative. In other words, find the gradient at various points along this graph. So one question that you could be asked is simply to find the marginal cost when the production is 100 units per day. And all you have to do is come here and get the gradient. So how do you get the gradient here? You simply find the first derivative of this function. This other question asks, well, at what level of production is the marginal cost 0? And all you have to do is come along here and look for where the gradient is 0 and get the number of units being produced. So I hope this video gives you some idea of where the idea of the derivative is applicable in various subjects. There are many, many more examples that exist, but I think this should suffice for this introductory video. So in the next video, we'll look at how we can actually determine these gradients. In other words, determine the derivative of these functions. Okay, so bye for now.